ICITDA 2020. And right now we are in a workshop session with the title Workshop on Mobile Application Based on Deep Learning for Image Recognition. And this workshop will be delivered by Mr. Dhomas Hatta, Ph.D. Before we start our workshop session, let me introduce myself. My name is Ahmad Fathan Hidayatullah. You can call me Fathan. And right now, I'm a lecturer at the Department of Informatics, Universitas Islam Indonesia. And I will be serving as your moderator for this workshop session. First of all, I would like to thank to all participants for joining this workshop session. Hopefully, you are all enjoying this virtual conference. And secondly, I would like to thank to Mr. Hatta as a speaker in this workshop. And we are happy to have you here. Before we start the workshop, I would like to share you some information. And the first is to attend this workshop, we have some requirements. Firstly, you don't need to install. You need to access Google Colab, and I would like to share the link later on, or later on, Mr. Dhomas Hatta will share with you in the workshop session. And the second, you have to install Android Studio on your laptop. And the second information is this workshop will be divided into two parts, two sections, and we will have a short break maybe, if possible, or if not possible, yeah, we just go through until the end of this session. Maybe if we want to have a break, we will be have a break at around 3 p.m. for around 10 to 15 minutes. Yeah, for those who are need to pray for this time. And then the last information for those who has queries or questions, please you can raise hand. You can use the raise hand feature in the Zoom, and I as the moderator will allow you to speak or write the question through the chat room. Okay. Um, right now, probably I would like to read the CV of our speaker today. Our speaker is Mr. Dhomas Hatta Fudholi, Ph.D. He is assistant professor and secretary of undergraduate program in informatics, Universitas Islam Indonesia. His education backgrounds, he graduated from Gajah Mada, Bachelor of Engineering, and he finished his Master of Engineering at King Mangkut Institute of Technology, Lat Krapang, Thailand, and he graduated from Latrobe University. And right now, he has several publications, so many publications, yeah, and his research interests are about big data, ontology, natural language processing, and so on. Okay, right now, I think this is enough for me to deliver the introduction. Mr. Dhomas Hatta, are you ready right now?
Okay, can you hear me?
Okay, yeah, I can hear your voice clearly.
Okay,
Time is yours.
okay. Great. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. If you are in +7 time zone, good afternoon, and welcome to this workshop session. Let me introduce myself. So my name is Dhomas Hatta Fudholi, and now I'm going to share about a practical workshop or hands-on in creating a mobile app based on for image recognition based on deep learning. And before that, let me try to share my screen first. Okay. What happened? Hang on, let me try once more. Okay, great. Okay. All right. So as being introduced by Mr. Fathan, thank you very much, and thank you for everyone of all of you to attend this workshop. And let me try to give you some, kind of preface or introduction about what we are going to do in our hands-on workshop in this afternoon. So basically, we are going to do or to create a mobile app. Hopefully, in the beginning, I mean, like right now, you don't have anything, and in the end of the workshop session, you already have your own application. You did your own deep learning based application in two different image recognition tasks. So we are going to focus on two things in here, which are the object detection and the image classification. So basically, image classification is much simpler than object detection, but we are going to do both. Hopefully, we have enough time to train the model and to export the model, and finally to deploy the model in the mobile app, especially in Android platform.
Excuse me,
Okay,
Mr.
so
Hatta. Excuse
yeah.
me. Can you move your screen share or your Zoom, because the visualization is not clear because there is some
Okay.
noise here. Probably you can yeah, you can move your
Let
Zoom item.
hide floating meeting controls.
Okay.
Is that better? Or
There is still one noise. Yeah. Okay. In the middle. Okay.
okay, so
Right now it's okay. It's clear.
hang on. The video panel and the floating control. Okay, all good, right?
Still have one in the middle. Sorry.
Okay, hide floating control. Okay, because when someone's trying to get in the floating control, the meeting control
Yep.
coming up again.
Yep. Okay.
Hopefully, yeah, maybe I can just kind of move the window a little bit. Okay.
Okay. Go ahead.
Let's back to the slide. Okay, thank you. So we are going to focus on two things in here: the object detection and the image classification. As for the image classification, I'm not really sure, but don't worry so much. So I would like to make the baseline here so that everyone of you can actually follow what we are going to do. So we are going to start from the basic. I mean, you don't have to be a deep learning person or machine learning person, or you just attend this workshop to actually, I just want to develop the app with a deep learning or AI functionality. So that's okay. So this workshop is for you as well. So I will start from the basic. I mean, like, it's really practical. So you don't need to actually know the basic of deep learning, the basic of the CNN architecture or something else, the theory of machine learning or neural network and so forth. So you don't have to know that for now. But then if you are going to kind of improve the performance, or probably improve your models later on. So you probably need to start to learn to study about the basic idea behind the neural network, the CNN, and so on. But let me try to give you some bird view of how do we do this. So in image classification, basically, so we can actually classify image, yeah, something like this. So In the image classification, we try to actually classify image, whether, for example, whether it's a cat or a dog or an elephant or something else. And the way we do it is by, creating a network, a convolutional neural network. You may say CNN network, or that act as a feature learning or feature extractor. So basically, when we want our computer or our AI system actually, classify the pictures into some classes. So, for instance, okay, what this image is, within an image we have cats, or this is an image of the dog, this is an image of a frog or something else. So the way to recognize what is inside the image, what is the object inside the image, we do the feature learning. So actually we ask the computer, we ask the model to learn how to see some things. I mean, okay, this is the collection of a cat, for instance. The collection of a cat images. So we give that collection of images to the computer so that they can try to spot out. Okay, a cat is an animal that have furs and got a tail, four legs, triangle shapy ears, and with a little mustache over there, and so on and so on. So that's the way we also think. Okay, and when we see how can we recognize a cat is by their characteristic. That's why the characteristic of an object is learned first, and then we try to classify whether the images or the object is belong to one of the class. So that's the idea of the image classification. And in the object detection, it's quite similar. Yeah, so it's quite similar, but we have some differences here. In object detection, we need to also predict the location of the object. So we need to also predict the location of the object. And then when we have the localization of an object, we try to classify what kind of object is that with the classes that we assign in the model. Okay, that's some really brief introduction about image recognition, especially in the classification and object detection. Now, why we need to put this machine learning or deep learning? Why I just write machine learning here, because sometimes when we talk about, or when we say machine learning, deep learning is included inside it. So when we draw kind of a Venn diagram or so on, so deep learning is inside the machine learning topic. So when I say machine learning here, deep learning is also included within. So why we need to consider running a model, a machine learning model or deep learning based model on mobile or edge devices. So therefore, there are 4 points that we can highlight why we need to know about this, and why we want to develop application on a mobile, an AI-based application, whether it's machine learning based or deep learning based on a mobile. So there are 4 key points that we can highlight in here. The first one is latency. So when we when we run the model on the device itself, so there won't be much problem in the latency aspect. So there is no round trip, kind of data communication to the server, since the calculation, computation is run on the mobile itself. That's the first one. The second one is privacy. So if we infer our model within the mobile, so there's no data that we need to actually send or leave our device. So it's kind of, privacy things happening here. So we can keep our own data, and we don't have to worry whether our data is going to be sent somewhere else or somebody keep our data somewhere. The third one is connectivity. So when we can once again run or infer, do the inference of some, probably image recognition inference. If we can do it in our device, so we don't actually need a connectivity in here. Yeah, for communicating to the server, that's one thing, and probably communicating to other party. Yeah, so we can do our own computation and our own inference in our mobile devices. The next one is power consumption. So when we can do everything offline, so we can save the power resources from our devices, so that it's going to be, you know, uh, saving the resources. Yeah, you can say like that. Okay. And to do this, so there are researchers from many parts of the world created so many kinds of architectures that I showed you. This one is kind of, generic architecture, but then many researchers try to create a specific mobile architecture for the neural network. Yeah, when I say neural network, it's also include the convolutional neural network as well. So you can see here there are SqueezeNet, MobileNet version 1, version 2, version 3. There are no version 4 at the moment, but then they are created by Google, and then Google moved from MobileNet to EfficientNet and EfficientNet Lite. So I don't see any version 4 for the MobileNet, but you can see there are many kinds of mobile architecture that you can try to think that you can try to learn or implement to create an AI-based or a model to do image recognition. And for the current state of the art model, you can, if you are a Google person, probably you can try to learn or to focus on the efficient net. That's the architecture that we are going to use in this workshop. And it started to be published at 2019, and I guess in this year it's still being improved. Yeah, the efficient net. But MobileNet version 3 is also a new architecture that just came out like last year. Okay, so what we are going to do is our workshop or our hands-on about. So this is a very, it's not actually basic. I can say it's very basic level of workshop, and it's zero experience required. So you don't need to actually need to know about deep learning or machine learning at the moment. But then if you want, once again, if you want to actually explore more about what you are going to do this afternoon, you can try to learn one or two things first, and then go on with the things that you like more. And it's really practical. So we are going to do live coding, but we already share the Google Drive link. So basically, there are two IPython notebook or two Google Colab files that consist of script that we are going to use in this live coding session or in this afternoon hands-on. So you can just open it, and probably you can I'm not sure if you can directly run it because there are some specific script that only you can actually, it's different for everyone, for every different person. So especially on the Google Drive section, we will show you later on. And the tools that we are going to use is Google Colab and Android Studio. I'm not sure if you already installed this Android Studio software. It's quite big software, and hopefully some of you, or probably most of you, or ideally all of you, already installed the Android Studio software. And we are going to use the TensorFlow library and also the TensorFlow Lite, and and we also use the TensorFlow Lite model maker. And this is end-to-end tutorial. So I hope in the beginning of this hands-on or this session, you don't have anything. I mean, you never had a mobile app with a deep learning model inside it, and then in the end of the day, like in 1.5 hours from now, you will have one or two. You will have two applications run on your mobile devices. But unfortunately, we are going to use the Android platform for today. For the iOS, it's not covered, but probably you can if you are iOS users, probably you can take the ideas from this hands-on to later on implement the ideas in your platform. So what will we do? So we are going to build the model and export the model, and finally we deploy the model to an Android application. Okay, this is references that I used. I think this slide will also be, I will put this slide later on in the Google Drive, so you can download it later. Okay, let's move to the hands-on. Okay, now please open your browser, probably Chrome or others. Hang on, I opened mine. Okay, there you go. There are a lot of chat here, so hopefully. Okay, probably I can ask. Yes, I will share the slide. Thank you. Okay. Right. Please open your browsers, and then no, just only one is enough. So not browsers, just one browser is enough. And navigate yourself to your Google Drive directory. So in my case, I'm not using my institutional account. This is my personal account, just to make sure that we are on the same page. Maybe some of you not coming from from the Universitas Islam Indonesia or UII or any other universities or other universities that has Google Edu services. So I'm kind of trying to make myself in the same level as yours. So I'm using my personal email address to actually do this. Okay, now this is the folders that we shared it to you, and there are many things. It's actually kind of mixed up, so probably don't get confused at the moment. So I will try to give you some clues along the workshop. Okay, along the hands-on workshop. Okay, let me try to open this in the new tab, so I can open these things. And okay, now you can try to create a folders as you want, or kind of we make it as our working directory. So for instance, I put live session in here, ICITDA. That's a long name. Okay, no worries. Okay. So I'm going to use these folders, and everything that I'm going to use, like the data set or the models, the exported models and so on, I will try to make this our home directory or our home working directory. It's kind of our working directory. Okay, let's just say that. Okay, now let's try to create a Google Colab files. I'm not sure if you already have this menu, but hopefully you are, because I'm using just an ordinary general account. So hopefully you already have this menu. And now let's create a Google Colab files. There are 2 people entered the waiting room. Okay, maybe Mr. Fathan can help with that. Okay, come on. All right. Now let's rename it as you please. So in my case, I name it object detection. So let's start with the object detection first, since it's going to take longer to train than the image classification. Okay. And probably you can try to open this object detection IPython notebook as well, so that if you want to use that, yes, probably you can, but probably you can't, because there are a setup on the Google Drive that probably specific for each person. So you may you may need to edit the script yourself. Okay, now, before we start, let's pick the runtime first. Let's change the runtime to the GPU runtime. So here's the story. So when you heard about, probably some of you, or probably most of you already heard that, okay, when people try to train a models, or especially image-based model, usually they use GPU to actually train the model, because it's actually can give you a faster computation, training, sorry, not computation, faster training process. Why? Even though GPU processor is not as fast as CPUs, but GPUs got a lot more cores. So when we want to when we want to do something about image, when we take image as our input, or as our input. So as you know that GPU is working in your computer to actually display something, in your computer as fast as it can. And you know that your monitor has a lot of pixels, and the GPU try to actually render all the picture at the same time, even though it's not as fast as CPU. But GPU has a lot of cores in order to to display the picture in your monitor in actual probably in about the same time. So during the training of image-based classification using the CNN or convolutional neural network, it is better for you to actually use GPU, because it will give you a lot more faster training process. So in this case, I tried it before. If we use the same script, if we use the CPU, or the basic, or the base, or the generic, or the base runtime in the Colab notebook, it will spend around 1 second for each step. But then if we choose the GPU, it will be 10 times faster. So we choose the GPU as our runtime. So we click runtime and change runtime type and choose the GPU. And let's start coding. So let's start with installing the TensorFlow GPU version 1.15. So you can just copy and paste this script, or you can just rerun the collab files from the drive. Okay. So we uninstall the current version of TensorFlow in our Google Colab environment, and then install the TensorFlow GPU version 1.15. Okay, why we are doing this? Because the API, the TensorFlow API that we are going to use is the TensorFlow API for the TensorFlow version 1. So there are two versions of TensorFlow, and the TensorFlow object detection API for the TensorFlow version 2 is just released like recently, a couple months ago. So it's kind of, there is still many improvement needed to be stable. So we are going to use the version 1, and to be exact 1.15. Okay, and then you can during the installation, I'm not sure why it takes long time. Okay. And then since we want to put our files in our Google Drive, so we don't spend much resources in our disk, so we need to actually mount our Google Drive folders. No, our Google Drive, yes, the drive itself, to our project in Collabs. Okay, done. And then we execute this script. Just copy paste, and then click this thing, and to authenticate, to give the permission. So I'm using this account. Okay. And I'll click allow. Now you need to copy this token, and where is it? Okay, here, and paste it here, and click enter. Okay, now your Google Drive is mounted in /content/drive. Okay, now let's move our current working directory to to the directory that you are going to use to be your working directory. So in my case, it will be live session ICITDA. So live session ICITDA. Like this, okay? Now our current working directory has been moved to this directory. So it may be different from mine to yours. And if we want to check our working directory, we can type pwd, okay. All right, and then now, okay. I think hang on, where I put the oh, okay. Now, what we are going to do first is we need to have our own data set. Okay, we need to have our own data set to be our training set and test set for the image, our object detection model. So in this case, we are not going to actually create our own data set because it takes time, but we want you to use the existing data set, and then later on I will try to give you some clues how to create the data set. But we are going to use the existing data set. Let me try to uh, give you the link where to find the data set. Hang on. Okay, I'll use where's the how can I give it, Mr. Fathan, can you
Yes.
pass it to the chat, because I'm using my Mac and I'm
Yeah.
connecting to Zoom with my PC, so
Okay.
it's kind of
I shared before, but
uh,
probably we need to share again one more. Okay, thank you, Mr. Satya.
no, the one that I just sent you
Oh,
in WhatsApp.
oh, sorry.
Yeah,
Okay.
can you
Okay,
share it
okay,
to the
okay,
chat?
okay.
Yeah, thank you. That one. So we will use the data set from this tutorial in here. The TensorFlow Object Detection API tutorial, train multiple object, Windows 10. We are going to use the data set in here. So what we are going to do is we can try to clone this GitHub. Have you ever tried to clone the GitHub? Okay, just copy. When you open the page, you go this to this part, and then you copy everything here. Copy everything here, and then go back to this collab, and then we want to download it. Oh, sorry, it's not wget, but it's git clone, and probably I would like to name it source. So the like a data source or the source. Okay, so I will clone this GitHub into a folder named source. So that's the same thing as the source folders in the Google Drive that we share to you. So this folders is the git clone of this GitHub work directory. Okay. And then after that, after it finish in your Google Drive, you'll see that there's new folders in here. And later on, okay, let me just go back to this page. Okay, it's finished. And then you can try to have a quick look to your Google Drive, and now you have this folder. Okay, you have this folder. Okay, so once again, how to do the git clone. So you put the exclamation mark, git space clone space the address, and then if you want to save it to some, in my case, I will make the folder name short, and I call it source. Okay, and then when you go back to your Google Drive, there are a lot of things happening here, and we will use the image data set in the images folder within the source folder. Okay. All right. So now, what kind of the data set that we need? As you see here, so there are a lot of playing card images here. So in this case, we were going to make a model to differentiate, to detect what kind of cards that we have. So in this occasion, there are 6 classes. So ace, the king, the queen, the jack, and the 10. Okay, and the 10. Sorry, 10 and 9. So there are six classes. So we collect these images by ourselves, or you can, kind of take the picture yourself. And then, as you see here, every image there is for every image there is a corresponding XML files. So the XML files contains I hope you can see these things. Hopefully it's not too small. You can see the detailed information about the image, and also the location of the card, and this is the label. Let me try to a little bit do a zoom in. Can I? Okay, yeah, that's great. So, for instance, in the image 18, so we have one ace here around in the middle, and this is the XML file that act as the label, the annotation or the annotation of the image. So this is the detail of the image, and this is the label of the image. So in about this position, so we have ace. Okay, so that's the annotation that we have to do uh, to create the dataset for our object detection model. So how we do that? Do we need to actually write all of this every time we have an image? No, you can use uh, a tool called label image. So you can use a label image software or application to actually help you to label your image. So basically, I think we have some clues in this page as well. Uh, okay, so I'm not going to show you the application because it's going to spend some times. But to give some some ideas what happened or what kind of software label image is. So when you use this software, and then you just need to actually open your image, and then you make some binaries of the image, and then you put the label for that object. So for instance, this has 4 cards, and then you create the boundaries here, square boundaries, and then for each boundaries you label it based on its on the class that we want to detect later on. So for this boundaries, this is ace, and this should be king, and another ace, and this should be 9. You put the label in this box, and then you just need to click save. Where was it? Okay, here. Click save, and then you will be given the XML files automatically. So you don't need to actually create the XML file one by one. So you can use this software once again to create the dataset. Okay, let's go back here. Then um, hang on. I guess I missed some of the. Okay. Now, when you finish, collecting the data, creating the XML file for all your images, you need to create the CSV for all the images. These CSV files act as kind of summary of what image you have. So you put or you split by yourself how many image on the train for the train set and for the test set. Okay, so you need to split yourself how many image you want to put on the train set and how many image you put on the test set. And then you need to create these CSV files that contains a summary of what kind of cards you have on each folders, on each data set. I mean, on the training data set or on the test data set. Okay, so it's kind of summary. Okay, all right. And how you create these CSV files, actually you can use this Python script. So you can use this Python script to convert the XML that you have to CSV files. So you just need to actually I guess you need to just actually run this script, because it's already being set that we have two folders, train and test. So we are not executing this because we already have the CSV files. But if you need to run it later on, you just need to call Python, and you just need to do this Python and XML to CSV .py, and that's it. Hang on, you need to complete this with the correct path. Okay, but we already have that, so we can skip this. And after we have the CSV file, we want to convert again. Okay, I don't know why it's happening at the first time, but that's the thing. So you have to convert the CSV file into two rec.record files called train.record and test.record. So you can now copy the script again from the given source, from the given files that I already gave it to you. Can I actually make it bigger? Okay. This script. So we want to go to the source folders, these folders, and then we want to generate the TF record for the training set and for the test set. So you already given the generate TF record.py for both. You need to execute for both data set. For the train data set and for the test set. Okay, and you can just run it. And when you, oh, hang on. Oh, okay. What's happening here? Module not found. Okay, so, all right. So I think we have to do this later. So we need to keep it for later. We need to do something else first, which is to get the TensorFlow models, the TensorFlow API to actually train the object detection. Okay, to train the object detection. So we are going to do this. I will let it use small name. So So what we are doing right now is downloading the TensorFlow API to train the object detection model. Okay, and then okay, let's skip this at the moment, and we execute the next script is to to create the executable files in for the object detection. It's kind of giving you kind of compiling, okay, kind of compiling all the resources that is stored sorry, in the TensorFlow API that we just downloaded before. So now we have these new folders called models. So within the models folder, it's the TensorFlow API that we are going to use to train the object detection. Okay, and then we are going to execute this. So it's kind of compile the function or the in within the API so that we can use it later on. Okay, just execute it. That's it, and we create another cells, and then just copy the next script. We are going to use this to actually install to build and install the API. So it's going to take some time. So let's start executing. Okay, we finish. Okay, great. And then we need to install the additional library if it is not installed. Using this script, you can just once again copy paste from the one that I gave you before. Okay, and then when we finish this, we should be able to do this, hopefully. Okay. Okay, don't worry about the warnings, but we successfully create two files within which is the train.record and test.record. Okay, within the source folders here. So we have, okay, let me try to zoom in a bit. So we have test record and train record. So this is the collection of the train data set and also the test data set. All right, next. Let's create a training folders and create a pipelines for training. Okay. So we are going to create another directory. So we are going to call this directory a training directory. So we are going to keep all the checkpoint, the training config in this directory. And then you can try to use, before that, from the source, we are going to copy one files. Where is it? it's in the training folders. Okay. In the source and training folders, you have label map.pbtxt. You can create, make a copy and then move it to the training directory, or you can just move this there. Okay. So what is inside this .pb.txt? If you can we actually it consists of a label. It consists of a label. It's something like, let me show you what it looks like. Since we cannot open it in the Google Drive, so you have to actually download it if you want to see what is inside. So you can try to download it. Okay, try to download it, and then let me try to open it for you. Okay, it looks like this. How can I zoom in with this? Okay, it looks like this. So it consists of labels. It consists of labels or class that we are going to use to classify or to detect our object. So as I told you before, we have six classes, and now we have six IDs here, or 6 items. So we are going to classify the card into as 9, 10, Jack, Queen, King, or Ace. So this is the thing that you have to provide as well before you train the model. Okay. So you can try to make a copy, for instance, and then the copy, you can move it to the training folders. Not this training, but the training at the front that you are going to use here. And don't forget to rename it. Actually, you don't have to rename it, but for the sake of consistency, let me try to put it back as a label map.pbtxt file. Okay. So another files that we need is the config files. So there are many kinds of architectures that we can use, right? In mobile in a mobile architecture, there are many kinds of mobile architecture that we can use, and we can see it from here, like TensorFlow Model Zoo. Oh, why it's not changing? TensorFlow Model Zoo. Okay, so you can click this link, the second one, and then you will get this page. Let me try to copy the link and pass it to Mr. Fathan so that he can paste it to the chat room. And as you can see, there are many architectures that we can use in this API, but there are a couple models that actually designed for mobile devices. Yeah. So what is the difference between the mobile specific or mobile design architecture with other architecture? A mobile design architecture usually got a fewer parameters, but it may be not as good as the big one, as a non-mobile architectures, but you know that in mobile, when our mobile device or our edge device is going to be used to do the inference, so with limited resources, so we are given, or the researchers already create a small architectures or architectures that is designed for a mobile with smaller numbers of parameters than other architectures. So we have a mobile net version 2, version 3, and version 3 large and version 3 small. Okay, as for now, we are going to use the SSD mobile net version 3 large architecture as our base architecture, or our base model architectures. Okay, we are going to use this, the SSD mobile net, but you can try another architecture later on. So we need to download that base architectures, because we are not going to start from zero. We have something called transfer learning, but I'm not going to give you the details now. So it just means that we are not going to train from the really start or the very beginning of the things, but since some other people's already try to create a good model, so you can use that parameters, we can use that kind of checkpoint to start from. So we are not if we want to go to the finish line, we are not starting from the start line, but from the checkpoint in the middle. So we are going to get hopefully faster and better models. Okay, so let's go back to the collab, and now let's download the models to our directory. Okay. All right. And then when we finish downloading it, now let's try to put, or you can try to download this. Hang on, let me add one more files in here, in that directory, so that you can use later. So it's the pipeline config files. Hang on, where was it? Okay. Okay, let me upload it a moment. Okay, it's uploaded, so you can try to refresh the folder again. And now you see this this mobile net version 3 large.config. Okay. Okay, since we cannot edit these files straight away in the Google Drive, so you need to download it first. It's not big, so it's very small files, because it's text files, so it's no harm for you to actually download it and open it in, for instance, in Visual Code Studio or other text editor. Okay, please download it and open it in one of your text editor first. Okay. Let me give you 1 or 2 minutes. Okay, hopefully you already opened the files in your computers, your own computers. And then there are a couple places that we need to actually, give our attention to. First is this in line number 14. In line number 14. So, okay, so how can we actually make this config? It's so complex, and how can we make it? So actually, you don't need to actually make it from the scratch, because the TensorFlow API give you in here give you the sample of the config file. So when you go to models and research and object detection, and then you go to the sample folders, and you get this folder. It calls configs. So when you double click the config folders, you'll see that there are a lot of kind of template. Okay, it's the template of the config files for almost all of the architectures given in this model zoo page. So you can see here, if you're using probably SSD mobile net architectures, you can kind of find, okay, you can choose this one or this one as your kind of template of your config. So you don't need to actually create it from like real zero or from the scratch. Okay. Let me go back to, so here's the location. So models, research, object detection, samples, and configs. So let me go back to the train folders, and let me go back to the here. So there are a couple places that you need to be aware, or you need to give your attention to. The first place is this, the parameter of number of classes. So this is the number of classes that you are going to train. So in this case, you have six classes, right? 6 classes. And so you put 6 in here, and then you can just, go through. We are not going to discuss all of this. But then you'll see in the image resizer, this is kind of JSON file, yes, you're right. And in the image resizer section, you can actually try to modify these values. So if you want to, your models to give you a better performance, usually we make this value higher. So we resize the image into a higher resolution, for example, 640 or 1024. But then your computer need really good resources to actually train the model, because the image is going to be big. So in this case, I'm just going to use the 320 pixel for the height and width as the input images resizer that will going to be the input image that goes through the architectures, which is the SSD MobileNet version 3 large. Okay. And so you can modify this. Usually it's the multiplication of 32, but let's just keep it quite small. And then this is the feature extractors. So since we are going to use the SSD MobileNet version 3 large, so we put this. But then if you're using different architectures, you probably will find the type of feature extractors value different. So if you are using mobile data, so it's going to be SSD mobile data and so on. Or if you're using SSD MobileNet version 2, it's going to be set SSD MobileNet version 2. So it's going to be different in each config files. The next one that probably you want to be point in is this fine-tune checkpoint. So if you're going to use the existing parameters, or doing something like transfer learning things that I'm not going to explain in details. So we give this. So you need to change the directory name here with the working directory that you use. So mine will be live session, ICITDA, I guess. So live session ICITDA. Okay. So this path is going to be pointing to this model. Okay, so it's kind of pre-trained models. Okay, so let's go back to the Visual Code. And so you need to modify these things, okay? Especially this part, I guess. And then let's just, this is the batch size, this is the number of steps you can modify later on. Okay, let's just keep it 25,000. So, but we can try to stop the training if we think that it's enough. Okay, so this is if this is the setup for the learning rate, and the other things that you want to um, change is this part. So this is the location of the train board that we just created before. So in my case, it will be live session ICITDA, and it's going to be in the source. Let me take a quick look because I forgot where the source and the source. Okay, just source. Okay. So, I'll see just the source, and we can remove the others. Okay. So this is in my case. So the location of the train record. So you need to change the location to match yours. The path of the train, sorry, the path of the train record and the test record that belongs to you. And then this is the label map pb.pbtxt location. So in my case, it's going to be like this. Okay. Let me double check. So we have live session and training, and yes, that's there. Okay, and then this is the number example of images that is located in the test folders, in the test image folder. So this number refers to how many images later on that you are going to use as the test set. That's it. That's all. Okay, and then you can save it. When you finish, hopefully I make everything right, the path, okay, you can double check, and then afterwards you can put the config files in the same folders in the training folders. So you can put the config files here. Okay. If you use a Google Drive file streaming, you can actually open it from your finders or folders straight away. But if you are not using a Google Drive file streaming, you can do it like this. Okay, our preparation is complete. Now we move back to the Google Colab, and now let's start training. You can use the script, this script. You can use this script, the one with train.py in the end of the first line, but then you need to modify this since the training folders is just right under the working directory. So I just remove everything except the training, and the config is also in the training folders. So like this. So it's going to be different with yours. So please try to match the path with your own path, and then we can start start the training. Hopefully it's working. Okay, please ignore the warnings. How do we know that the training is working? So we can see later if it's starting to calculate the loss, the step is running, and so it's already started. So in here, Google's kind of lend us a Tesla T4 with 40 gigabyte of memory. It's free stuff, which is it's more than enough. Okay, it's more than enough for free stuff. Okay. Now the training is already started. See, so the training is already started. For each step, it takes 0.1 second. So it's not that long. If you use CPU for your runtime, it's going to be 1 second for each step. So it's going to take like forever. So if you want to do all the 25,000 steps, it will take, I did it this morning, it will take around 2.5 hours probably. So we don't have that much time. So probably we were going to go back to this part later, and maybe we will stop in some point and export whatever we have. So the training will be locked. So this is the log. In the training folder, you have the log of the training. So don't worry, in a Google Colab, as I remember, you only have 12 hours of session. So after 12 hours of running, I'm not sure if they give more, but then your session will be stopped. But don't worry, when your session is stopped, you can just re-execute, rerun this script. And then the training process will continue from the latest checkpoint. So don't worry if the Google stop giving you session, you can just execute it again. Okay, let's just leave this for now. Okay, let's just leave it for now. All right, let's move to the image classification. let's leave it. It's going to take some time. Okay, let's go back to our working folders. Now we are going to create another Google Colab files for our image classification hands-on. Okay, let me give you 1 or 2 minutes so that you are in the same page as me, as I rename these files with image classification. Okay. Okay. The task of image classification, as I said to you before, is just to classify images. Whether the image is, for instance, we want to classify whether the image is the object within the image is a cat or a dog. So yeah, so the system will that we create is to classify or to give us the result of inferencing whether the image is cat or dog. Okay, we are going to use the TF Lite model maker. This library, okay? When we use this library, it's going to be very quick way to create image classification models. Okay, so basically, if we use this library, we just need to have how many lines of code. So we just need to have, if we exclude this import, so we just need to have one. Oh, sorry. Let me split it into two different cell. Okay. So we have one line to call the data set, and the second line is to create the classifier to read the data. And the third one is to split the data into the training and test data set. So we have three here. And then the fourth one is to actually train the data. We do the training in this. And then if you want to, you can evaluate the models. So we have 1, 2, 3, 4, 5 lines. And finally, we export the models so that we can use it. We can call it. We can use it in our Android application. So we only have 1, 2, 3, 4, 5, 6, and that's it. Okay, so it's very simple to actually create an image classification model. Okay, let's try to execute this one by one. Firstly, we install the TF Lite Model Maker. Okay, if you have sometimes, and if you already have Android Studio installed on your computer, please download these two zip files because it's going to take a while. It's around 80 megabytes or something. The Android app for the object detection and also the Android app for the image classification. Please download these two zip files and extract it somewhere in your computer or laptop. Okay, still installing. Let's have a look. Okay, so as you see here, the loss should be going down, and it's going to be smaller and smaller during the time. But we still in this step. We have 25,000 steps. It's around 2.5 hours. Okay. Okay, it's done installing the TF Lite Model Maker library, and then we just import everything here, and then we need to download the data set first. Okay, in this case, we use. Let me try to put another cell here and download the data set. It's a Flower data set, and we put it just right under our working directory. So we need to change this image path into live session. This is in my case, so yours might be different. Okay, so what we have here, so we are going to have another, not here yet. It takes some time to sync from this. Where is it? Okay, we have sample flower photos here, but we still miss it here. Okay, because it takes some time to actually sync back from the Google Colab to our drive. But what we want to know is that within the folders, so to do the image classification, it's really easy. You just need to collect all the images within same classes. For example, all Rose's images is stored within Rose's image. And later on, the name of the folder will be the class name. So if you want to put another flowers, just create a folders and um, put the pictures or image just right there. Okay, uh, and then yeah, that's it. So the easiest way to actually collect the photos or the image of an object is by using a Google image or probably Bing search engine, image search engine, and then do scrapping and store it in the folders. Okay, in the folders. There are probably if you give some effort a little bit, you may find the script to actually scrap those images from Google image search engine or Bing image search engine and just put it together in one folders. Okay, so that's how you actually once again create the data set for image classification. The easiest way to use a scrapping method uh, in search engine. Okay, and then let's execute this. Let's see, still not there yet. Okay, no worries. uh, let's have a quick not here, have a quick look content. Hang on. Oh, I forgot to I think I forgot to mount the drive. Okay, that's okay. So the location of the flower photos will be here, not in our Google Drive. It will be here. Okay, I missed in mounting the Google Drive because it's different session with the other one. So you need to actually mount it again. So okay, it's going to be here, content and content flower photos. Okay, that's good. And then we want to split the training and the data and the test data set with the ratio of 0.9. So it means that 0.9 or 90% of the data will be the training data, and the rest will be the test data, and that's it. Oh, sorry. We need to execute this first. Okay, we have 5 labels, and we have quite a lot of a lot of images, and then we do the training. Is it really like that's it? No other things that we are going to do? Yes, that's it. If you are going to use all the default settings, that's it. The default settings of the image classifier object in here when doing the training is to use the efficient net light 0 architecture as the base model. So efficient net light 0 is used as the base model. If you want to use different kind of models, you can modify the script. Hang on, I'm not a dictionary, so sometimes I forgot what is the script looks like. Okay, please bear with me. You can try to do this kind of things. So you may add this here. So you may add another parameters called model spec, model spec.mobilenet version 2 spec. So if we do this, the training will be or the model, the base model, the base architectures of the model that will be used is the MobileNet version 2. And we have another the TF Lite model maker has few predefined models, the MobileNet version 2 and ResNet 50, I think, and EfficientNet Lite 0, EfficientNet Lite 1, EfficientNet Lite 2, 3, and 4. Okay, but if you want to use another architectures, or for instance, like Inception version 3 or other architectures, you can go to the TensorFlow hub.dev. So it's pretty short link. So you can just click that, and probably you want to use Inception version 3. Feature factors. Okay, so there are a lot of there are more base architectures that you can use instead of just EfficientNet Lite 0 till 4, MobileNet version 2, and the ResNet 50. So you can use the another architectures that is available here. Okay, let me just copy this link and give it to Mr. Fathan so that he can share it with all of you.
Okay.
All right, so let's see. Okay, it's going to take a while. Okay, well, we are waiting for the training to be finished. Now let's open our Android Studio software. Okay. Okay, let me try to start from the beginning, the very beginning. Okay, I hope you already download these two apps. Let's start with the image classification first. Okay, let's start with the image classification. And when you open the Android Studio, okay, I will try to put you on hold like for 1 or 2 minutes so that you have some time to load or to open the Android Studio application. I'm using the latest version of the Android Studio. I just updated last night, the version 4.1.1. Okay. Well, we are waiting. This should be not as long as the object detection, but we still need to wait for it to be finished. Okay. Move back to the Android Studio. Hopefully you already opened the Android Studio software, and just click open an existing project and point to the folders of the extracted folders of the Android image classification.zip. So point to that folders in your case. In my case, it's here. So don't worry about where I put the app. So basically, you open the folder where you get the app. Let me try to show you. So you. Example slide. Oh, sorry. Wait a minute. Okay. All right. So small. Okay, don't worry. I hope you still can see it. So basically, you navigate to the folder that has app, folder app, and other Java script and so on. Okay, so let me try to explain to you a couple of things. Okay, to make it quick, we are going to put our models and the labels inside the asset. So can we actually make it bigger? Zoom. No, it's actually maximizing.
View, and zoom in.
Okay. Because the resolution is
the top menu, probably.
Can I zoom? No. Hopefully you can see it. So within the app here, when you open the project, okay, before it actually can open, usually you will be given some windows or warning that you have to sync the Gradle. To sync the Gradle, just click OK or click sync, so that you can have the latest, not the latest, the configuration of the current Gradle that is used in this application. Okay, just do it, just sync it. Okay, and when you finish to sync the Gradle, so you open the app and then open the assets folder, and within the asset folder, you in this folder you will put the label of the class, which is daisy, dandelion, roses, sunflowers, and tulips in this case. Hang on, let me try to. How can I zoom in? Is this how I do it? No. Somebody know how to zoom this in. Oh, this is search, not zoom. Search also.
Windows Zoom probably, Pak Hatta.
Sorry?
Windows Zoom, probably.
No, this is to actually maximize the window, okay. Not really zooming in.
There is no zoom in.
Yeah. How to zoom?
Or Command ++ maybe?
No, it's not working. Okay, so I don't think. Is it? Can you actually maybe a little see it? Not clearly, but can you actually read these files as labels.txt? Are you?
Yes.
Yeah. Okay.
But
so okay.
It's too small, right. I think.
Yeah, it's quite small, but I don't know. Maybe somebody can help. Control more scroll. I can't do that as well because it's on my extension display and it's streamed to Zoom. So I've tried that, Dian. Thank you, but it doesn't work. Okay. Now let's move back to the app. So the folders that you want to be aware of is the asset folder, since you want to put the models and the labels in these folders, and then you might want to open the Java folders, org, TensorFlow, like examples, classification, and you open the classifier activities. So this is the script, the interpreters, okay, the interpreters to do the inference. Okay, it is being scripted, or it's written in these files. Okay, do we actually we already have these models and labels, but if you are curious, how can we have that? Because it's still not finished. And when it's finished, and then if we want to actually evaluate the models, we can do this. We can run this script, and then to export the models so that you can have, so that you can get the labels.txt and the model.tflight. So this is t.tflight representation. So the model is straight away converted to TensorFlow Lite version of the models representation. So when you finish doing the export, and you specify the export directory, and let me try to change this live extension ICITDA, and we put it in the exported models, and we don't want to put the metadata inside the models. So we put false in here so that we can get the labels.txt files in the same directory with the models. So when it's done later, we can calculate the accuracy and the loss, or we can say we can evaluate our models to the test data set, and then we export the models so that we can get these two files, and then you can just download it from the Google Drive, and then you just copy the files and paste it in the assets directory, And finally, when you finish, you can try to click the build. Hang on, why there is no device here? Okay. Now I need to connect my phone first. Okay, it's already here. And then just click run. When you click run, you actually create the APK, the .apk files, which is the Android application files itself, and then directly install the application to your mobile device. Let me try to run the app. Okay. And then when you got your application running, so let me try to stream it for you, the application. Hang on. I need to run my Pfizer app. Okay. Is it on? Okay. And then let me view my phone screen. Okay. And then let me show you what happened. Okay, so this is what happened when you run the application. So you see that the application start to classify the image. So this is Rose. Yeah, that's right. And you can actually, if your phone supports the GPU delegation, you can change the CPU processing, the CPU inferencing process to the GPU inferencing process. You can see that the inference time here is 56 milliseconds. But then if you change to GPU, it will much more faster. Okay. And this is roses, and probably I will try to find tulips. It's tulip. Okay. I'm not trying to sell these flowers because, okay, let me try to close the Tokopedia website. Okay. That's it. So that's what you get when you uh, execute or run this application in your phone, mobile phone. And that's what you got when you finish training the models. And okay, it's finished. And then you may evaluate the models, and later on you okay, since you want to export the models to the okay, I cannot export it to my drive since I haven't mounted before. So let's just put it in the content. Okay, this is the accuracy. So when you see that the training accuracy is not far from test accuracy, so it means that your models has a good, hopefully has a really good fit. So it's not overfitting since that your test accuracy is not way below the training accuracy. Okay, and then we export the models. Okay, that's it. Oh, why it's not changing? Okay, we have model.tflight and model.txt. So you just need to download these two files and put it just right there, and that's it. So I'm not going to really create the Android application from the scratch, as I'm not a developer myself. So yeah, I'm just going to use an existing template and just put the models there and make the application works. Okay, that's for the image classification. And it's already 15:52. Hopefully we got
Please,
something
we
here.
we, we still have 10 minutes maybe,
Okay.
or we can
So it's
end, yeah, more than 4 p.m. It's okay, I think, because we still don't have a question answer session.
okay.
So
Yeah. All
probably,
right.
yeah,
So yeah. Okay. So usually the best for mobile net version 3, the best number here for the loss is probably 0.2, 0.3. So it's still far from fit. Okay, so it's still far from fit, but then uh, if we have a lot of if we have more time, we can actually just leave it until it finishes, but we don't have much time. So uh, during the training, the API create the checkpoint. See, they create the checkpoint. So we just need now, for now, let's just stop this. Come on, stop. Or Control C maybe. Okay, let's just stop what we have right now.
it takes time probably. Yeah.
Okay, yeah.
Okay.
And then uh, we uh, we now try to export the models that we have. So there are two steps that you need to do. The first one is to export the checkpoint that you have into TensorFlow Lite SSD graph. I can't move. Okay. I just want to paste it here first. Okay. So the next one is you need to export the checkpoint into the TensorFlow Lite SSD graph and choose the checkpoint that you want to export. And when you finish the 25,000 steps, you just leave it as it is. But we are stopping this in the middle, so you can choose the latest, probably the latest checkpoint, which is the the checkpoint for the step 3473. So you can change this to the checkpoint, the step number in the checkpoint, the save checkpoint. What's the number again? 3473. 3473, like this, and then you can just execute it. And hang on. The thing is, you need to specify the output. Okay, the output directory. I'm specifying the output directory as no, hang on. This is the checkpoint is not within the model, so I need to change this. Okay, training models. So I need to change this as well. Okay, and I will put the graph within the inference graph directory. And when I finish, when you get your graph, you need to export the graph into the TF-Lite models. So you need to export the graph to the TF-Lite models. So you just need to consider these things in here, and the path, of course. And when you convert the graph to the TF-Lite files, you need to concern about this input shape. So make sure that input shape, you have to make sure the path of the graph and the input shape that you use. So in the config, do you remember in the config files, we used 320 times to 320 as the resolution of the input image for the SSD mobile map version 3 config pipeline that we use. So this resolution, this input shape need to be matched with the one in the config files. So here in here, okay. All right.
Excuse me, Pak Hatta.
Yep.
The committee asked me that we have to finish
Okay.
our meeting
Okay.
at
Let me
2 p.m.
finish
So
up
we
with.
only have no more than 3 minutes. Yeah.
Okay.
So
Uh, when let me just finish up or round up in the last 1 minute.
okay.
Hopefully you still can give that. So
Yeah.
when you have the models, the TF-Lite models, you need to download the models and create. Let me just show you the Android application project. Uh, this one. So you just need to take that models, the TF-Lite models once again, and put it in the asset, of course, in the same directory, and then you need to create label map.txt on your own. So you put the 9, 10, Jack, Queen, King, and Ace in the same order as the one in the label map.pb.txt, and then you need to put the question mark or just leave it blank because it's index 0. So the label start with index 1. So just leave it anything here, and then when you put the TF-Lite models and the label map, yeah, once again you can run the application. And finally, let me show you the final result of the application. So we have this object detection application. Let me try to find some card images, and hopefully I got something here. Oh, playing card probably. Okay, so we have here, it's not really, okay, here, let me try to zoom in, and That's right there. So it's a queen. So it's 10. So it's some misclassification over there because it's not complete. So if we try to pull out a little bit, so that's the thing. Okay. So that's the object detection running on your phone. Okay, that's it. I think that's all for today's material. I hope you can find something interesting and create your own project in the deep learning mobile application, deep learning based mobile application project. Okay, that's all. Thank you, Mr. Fathan. The time, I give the time back to you.
Okay, thank you. Really nice presentation. And we have a question from the participant here. Can you answer the question? Sorry, where can I get the classification activity.java? Probably this is a simple question. So show where
it's in the classification activities. Hang on. Let me move back to the other. Okay, it's in app Java and the org TensorFlow Lite example classification, and you have classifier activity. This one, right? In here.
Okay. Okay. Thank you, Pak Hatta. Hopefully, this answer your question from Mr. Dian Arianto. And then I have one question. Maybe what is the most important thing for those who are interested to research like this, and what is the most important thing to be considered during the process of building architecture? Probably the feature or the maybe what is the parameters? Yeah, maybe can you give me or all of us suggestion?
Okay, that's a really good question, Mr. Fathan. So, I had a project that we really have a lot of classes for the models. So as we know that a mobile base or mobile when the researchers create the mobile based architecture, they the key point they stress on the small size of the models, and also when we have a small size model, so with limited resources in our mobile device, we can still run the models. So when we have a small size models with the small size parameters, so it's going to be harder if we have a lot of a lot of different classes in for one model. So in our example, we only have six classes. So it actually performs really well in the inferencing. But if we have more than like hundreds of models, and we try to fit it in these small architectures, we may find it very useful. But then in some cases, we find it's difficult to actually detect the object. Why? Because there are a lot of differences. There are hundreds of different objects that we want our model to actually to detect, and that's kind of difficult. So there are trade-off between the mobile based architecture with the generic one, which is probably it will take for the mobile based model, it only takes like probably 11 megabytes or maximum probably 25 megabytes. If you try to put the big models in the mobile device, at the moment it will just make your device probably out of memory kind of things crash. So we cannot put the big architecture in our mobile device. So there is some trade-off once again. If you want to have a model that can classify a lot of classes, probably you still want to consider to have speaker moderator in the server.
Sambil lihat presentasi dosen.
Okay. Thank you for answering the question, Mr. Hatta. I'm sorry for all participants because the limitation of our time, so we have to end this session. So Alhamdulillah, we've got a lot of things from this workshop session, and hopefully this workshop will be beneficial for all of us in the future. And for all participants who want to get the recordings, we inform you that all of the recordings will be shared later on by the committee after the end of this conference. Probably after tomorrow, we will share our recordings to you. And after this session, I inform you to go back to the main session meeting. Probably 5 minutes to go, or maybe 4:15 in our Indonesian time right now, because we still have our last session for today, and we will have last keynote speaker from Dr. Jitstra in our last section. And okay, thank you for all participants, and thank you again for Mr. Dhomas Hatta Fudholi, Ph.D. for your presentation. Hopefully, we can meet again later on. Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Do we have a photo session? Danny, probably.
I don't know. Let's ask the committee.
Okay,
up to you if you wanna have it.
Okay. We just who will take the picture?
I will help you.
Okay.
Wait.
Please, all the participants, turn on your camera so you can take picture together. Okay. Hopefully all of you ready to take the picture. Hello, Pak Chandra from Japan. How are you?
Yeah, that's Chandra. Oh.
Assalamualaikum.
Waalaikumsalam.
Waalaikumsalam.
Okay.
Long time no see. Okay. We are ready, Bu Dani. Okay.
We'll take the picture now. Do you have any celebration or what? Or something like that? Okay.
Maybe, yeah.
Okay, I will take it now. 1, 2, 3. Okay, thank
One more?
you. One more? Wait.
Okay.
Wipe your hand.
Wait.
Okay. All of you, follow me. Hello.
Okay.
Okay, thank you.
Thank you.
Thank you for all. Thank you. See you later.